Hello. In this video, I will give an introduction to Staad Pro and we will create a simple model in Staad Pro. I installed the program. I click on the shortcut and I access to this window. Now let's talk about this window. Now from here you can reach the recent Staad Pro files which are saved by yourself recently. The most recent file is structure 1 here. This is its destination, and if there is a model in the file Staad Pro file, its appearance is also given here. I think it was a test file. I opened it, saved it as empty, and that's why there is no structure, no model in it, and nothing appears here. Okay, this is same. This structure, its appearance is given on the right hand side here, and so on. So to reach a recent file, you can use those buttons. And these are help topics. These are some web shortcuts. For example, if you want to reach help contents provided by the company Bentley, Staad Pro is a product of Bentley company. You can click on here. These are the help subjects, help contents. To reach the technical support offices of the company are given here. To reach the phone numbers, technical support and regional offices, you can use these buttons, and so on. You will understand what these are. There are some important things, and Staad news are provided here, but I have no connection to those news. License configuration is not important. Once you install the program to your computer, my duty is just using with license configuration. I have nothing to do. I forgot to mention, maybe there are some people who don't know what Staad Pro is. It is used for the aim of structural analysis and design of concrete structures and design of steel structures. And Staad Pro can make, in addition to linear analysis, some non-linear analysis and dynamic analysis. To the extent of my knowledge, to create a new project, as easily understood, the user shall click here. To open a project, the user can click here. But if you know the file name and it's your recent file, it will appear here, and you can use those buttons instead of clicking here and searching for the file which you want to open. This is if you want to open a Staad Pro file from the project wise, you have to click here. Project wise is a open pool. It's a knowledge pool which is provided by Bentley company. They have a server, and from their server, by means of internet connection, you can reach access to their server and find a Staad file in their server and open it from here. I have no access to their server. From here, we can make some configuration about the program. This is the backup manager, and this is the license management. With license management, I have also nothing to do now, because installing one program is another thing, and buying its license is another thing, and the license manager shall also be installed to the program, because license manager decides till what date the user can use it. But now we have nothing to do with installation and the expiration date of using the program. We are now focusing on using the program. The backup manager is important. Here in the backup manager, if you want that the program makes automatic saves when you are using, you have to you have to click here. And I think it's very useful because as a user I can forget saving my work, and if the electricity went off, I can lose everything. And for example, this means the frequency of backup file saving, it's 5 minutes. 5 minutes is too much. I think I want to make it 10 minutes because I don't want that the program asks me per every 5 minutes, do you want to save your data? This is the number of automatic save backup files. So as you understood, for example, once you have started, after 10 minutes, the program will save one backup file if anything goes wrong. And then after 20 minutes, the program will make the second save, and then program will make total 5 backup file savings. And in addition to that, the user can save your data. If this is one, normally, if I click on the save button, when after I finished working on something in the program, I click on the save button, and the program produces just one stat file. But if I write here 5, the program will make 5. Means that after I clicked 5 times to the save or save as buttons while I was using the program will keep all of those 5 versions of my data, my stat file. But I think it's unnecessary. Let's make it 1. And if you want to go back, and if you want to, it's like undo button. If you want to restore your file from the previous versions, you can write here 5, 6, 10, something like that. But I don't like to do it. I prefer writing here 1. Number of automatic save backups, I think 1 is also important here, but the important thing here is the frequency of automatic saving. I think this is important. You can make it 5, 3 or something like that. For example, 3 is not good, but an average value, 5 minutes, is okay for me. And this is the backup file destination. If you want to change it, you can use this button. Okay, the most important here is the frequency of automatic save, which is done by the program. I say click here. So backup manager, I spoke about it. License management, we have nothing to do with it. I also explained what the project wise is. It's also a folder. It's also a folder which is in the Bentley's server. And configuration. In the configuration, some things are important. There are some informations and some preferences. According to your preference, you can change some options from here. But the most important thing I want to mention here, the most important thing, in the base unit tab, the base unit is selected by the user. If you want to use metric units like meter, millimeter, Newton, kilonewton, you have to choose metric. If you want to use English units like pound, kilopound, or pound square inch, you have to choose English. Now I choose metric. The other important tab here in the configuration menu, working directory. It's here. If you want to change the working directory, you can arrange it from here. This is the default place or default address of the working directory. The another important thing is, I think this is important. Some people wants to work with black background, some with white background. Background color is important. It's here. If you want to work with white background, this option is chosen. With black, you have to choose this one. And the another important thing is global axis orientation. Now, the default vertical axis is y-axis in Staad program, and everybody does so. But if you want to, according to your special reasons, use z-axis as a vertical axis, you can change it from here. Because in many other programs, drawing programs, analysis programs, or in many books in the literature, in general, z-axis is used as the vertical coordinate axis. But I prefer to keep it now as y-axis. Some other things you can look from the other tabs, and if you want to change it, first of all, you have to understand what the meaning of those things, and using the help menu, you can learn the meanings of those other options, and you can change them from other tabs. But I think the most important things are those things. Now let's say accept. Okay. So let's start a new project. Okay. Now, file name is written here. Let's say introduction. Location. In my desktop, I create a folder, intro. I will save my Staad file here. Let's make the file name also shorter. The length you can also determine here. The default units are determined using the configuration tab, but after you start the new project, you can make also some changes here. Now the explanations are given here. When you are starting the new model, there are four options are provided here to define what your model is. But of course, you can start with a three-dimensional model, and after you launch to the program, if you decided to make it two-dimensional, you can make necessary changes in the program window afterwards. But here, space is a three-dimensional. New model is for a three-dimensional structure. A space structure, which is a three-dimensional frame structure with loads applied in any plane. That is the most general. Plane. A plane structure is bound by a global XY coordinate system with loads in the same plane. As you understand, this is two-dimensional for two-dimensional models. Floor. A floor structure is a two or three-dimensional structure having no horizontal global X or global Z movement of the structure. So floor structure is a 2 or 3 dimensional structure, but it has no horizontal movement, horizontal displacement. So the structure's shape is floor. You know, in structural buildings we have floors. This floor is same as that floor. The floor framing of a building is an ideal example of a structure. Okay, it is explained here. And this is truss, as you understand. Truss is, as you know, we have steel truss, not concrete trusses. And if you want to create a steel truss and make an analysis and design for it, it is better, it is suitable. You have to click, you must click here. Now I will work, I will create a simple model in 2 dimensions. So that as a result, I want to click here. And I say forward. Now here, I can start using some tools. This gives me a tool, this gives me another tool, this gives me another tool. This is a wizard. Using this wizard or wizard, the user can create very different versatile structures. It's better to start every one of them and show with what I will confront. For example, if you click on Add Beam and say OK, this window appears. Okay. Now this is isometric view. Okay. Remember, I chose Add Beam option, and arrived to this screen after the program launched. Okay. Now you see this is the perspective view. Y-axis is the vertical axis, X and Z axis are the other axes which are perpendicular to each other. If I want to look to the view from the positive Z axis, if I look to the positive Z axis, I will see the XY plane. So this option, with this option for easy drawing or creating on my model, I encountered with. This is Snap Not Beam option. It's a tool which helps me to create my structure easily. Okay, start from the beginning. If instead of Add Beam, if I choose Add plate structure, you know, first of all, let's make an explanation here. Here, by means of this tool, for example, I create Add Beam. The option was Add Beam. Okay, I clicked on 1, 2, 3, 4 nodes, 4 points, and then pressed on Escape in my keyboard. Now, if you click on here, this drawing helping tool will disappear. You see, I have a structure composed of 3 beams. You see, these are actually frames. Frame means beam, column, or beam column element. Okay, its length is very long in comparison to its cross section dimensions. This is the property of frame members in statics. So the important thing here to mention that beam in Staad Pro, beam means frame. In general, in the literature, we structural engineers know that beam is another element, column is another element, and some elements are beam column elements. But in Staad Pro program, beam is a jargon term for Staad Pro, and beam is given to all frame elements, which might be indeed a beam as a load carrying member, a column as a load carrying member, or a beam column element it might be. The other option, file, new. No, I don't want that it is saved. Okay, it's plain, two-dimensional. Add plate. Now, by means of, okay, let's click on finish. And I arrived to this screen. Again, I arrived to the same screen, a similar screen. Okay. A similar screen I arrived. Actually, there's no difference between them, but this time, okay, there is no difference. There is no difference. So there is no difference when someone selects plate or beam element, from my understanding. Beam element. Let's start from here. As you see here, the tools to draw a beam or frame element, you use the construction grid, drawing tools, and spreadsheets. But if you choose add plate, the used tools are the construction grid, drawing tools, and spreadsheets. So same tools are used. So there is no difference if you click on this thing or click on this thing. Add soil. Now this time my aim is to create a three-dimensional finite element, which is a solid element. Again, construction grid, drawing tools, and spreadsheets sheets are used. Let's say, let's click on OK. I arrived to the same screen. You see, snap node, drawing tool, the same screen, same same helper tools. Nothing differs. But here, open structure wizard or wizard, begin building your model by using standard parametric structural templates for trusses, surfaces, bayframes, and much more. This tool gives the user a lot of easiness. For example, let's say OK. Now, yeah, okay, that's true. Now you see, for example, I will create a frame model. I click here. Several different ready for use opportunities are given to me. For example, bay frame I want to create. I click on this. I double click on this. This model name is not important. Length, height, and width I decide from here. And number of base element, for example, 4. You see, if I have four base, 1, 2, 3, 4, and the total length is 12. So 12 divided by 4 gives me 3 meter bay length. Okay, this is the explanation. Okay, let's say apply. Yeah. Instead of creating nodes and frame elements, here in Staad Pro, instead of frame, we all say beam element. Instead of creating individual all those nodes and frames, using this tool, I created this frame model, three-dimensional frame model, very quickly. And then one shall click here, transfer model, or you can click on here, close, and it will ask, the program will ask you, would you like to transfer the three-dimensional frame model to the screen? If you say okay, this here you can keep all those values as 0. And you have the program. You can actually reach same option after you launch the program or after you reach to the program's interface here. Let's again speak on those things by the following x, y, and z values. If you want to replace, if you want to place your structure, your structures origin to the origin point in this window, all those points shall be 0. If you want to place your structure away from your origin, for example, in the x direction, 10 meters away from the origin, you have to write here 10. And instead of using giving some coordinate values to put your structure so much away from the origin, you can use some nodes, but I think this is okay. As you see, the second structure is pasted to the screen. Now start from new. I want to create a two-dimensional structure, but I don't want to use this tool now. I want to use Staad editor. What is it? Instead of using those graphical interface, you can use scripts, and you can type some scripts, and by this way you can create your structure, complete your analysis, and in addition your design. This is done by means of an editor like Notepad. So you can type your commands in the editor, and instead of clicking to those icons, you can do this. This is another option, but for new users, I think using graphical interface is easy. Yeah. Yes. So you write the commands here, and you produce your Staad file. This can also be reached after you reach to this window. The third option, edit job information. If you say OK, we actually reach to a blank screen, and in which there is no helper tool. There is no tool which is used to help us to draw easily our structural model. Actually, this is also okay for me because I can reach to these tools or to those tools after I launch the program. For example, I can reach to this tool from here, or I can reach to this tool from here, or I can reach this tool from here. So Staad Pro provides a lot of flexibilities till you reach to this window, but I think most of them are unnecessary. Now, after that point, I think it is better to show how very simply how a model is created and then analyzed, and the results, easy results, simple results, can be viewed by Staad Pro, because this is an introduction. Okay, and then I will say something about those icons. Okay, I want to use this tool. Now its view is isometric. You see, it's I will draw a two-dimensional frame. That's why I want to see it from the front, from plus z to the origin. From plus z to the origin, I want to look. Then I click on here, and I see that one. Now I will not explain what this tool is. I will just easily create create my model. Then I will explain it. I think this is easier to understand. Now in this tool, it is ready. If I create my frame, two-dimensional frames here. Okay, I click to this node. 1 means 1 meter, 2 means 2 meter, 3 means 3 meter. Okay, my columns are 3 meters height, 3 meters long. My beam's length is 5 meters. My yeah, and then I press on escape in my keyboard and I finish. That's okay. Now let's talk about this tool. Let's talk about this tool. What is this? Let me make some changes to understand what this tool is. Here I can make some changes, and by means of those changes, the grid here, which helps me to draw the model, changes also. Okay, let's make some differences, changes here, and see the effects on the left side. Now this is x direction, x-axis. On the x-axis I see numbers: 1 meter, 2 meter, 3 meter, 10 meter. And if instead of start I choose end, you see the effect is that. If I see both, you see the effect is that. If I choose none, that's the effect. I think both is good. Both is good. For y, the same rule applies for the vertical axis. If I choose both, you will see both boundaries. Both vertical boundary lines are numbered. This is easy to understand. One can snap to the intersection point of the grids, but if you now I don't want to make save, so I choose no. So you click here and snap to existing nodes is possible. So let's make some, and this is also, those things are not important for the fresh starter people, but to use this tool efficiently, some things are important. For example, here from the edit, you see the grid is provided in the XY plane. You can change it and put it to the other planes. You see, in the XY plane, our structure two-dimensional frame is created. If I say that the grid is provided to me in the XZ plane, you see, XZ plane is this plane, so it is carried to the XZ plane. So let's take it to its back place. The angle of plane is 0. For example, angle of plane YY, I am in the XY plane. That's okay. YY plane. So that means the angle deviation from XY plane. For example, we will see the effect. It's better to write an angle value here and see its effect. Now let's write here 45 and say OK. Now from here I don't understand what happens. But if I click here, I still don't understand what happens. But if I look from the top, I see the grid plane is rotated 45 degree from the XY plane. This degree is 45. This angle is 45 degree. Okay. So let's make it, for example, 90 degree. Okay. Now we see the effects after making changes. Let's put again 0 and look to the structure from front. So you can make some changes according to your needs to use this tool effective to create your structure. And the grid origin can also be replaced using this tool. For example, if I click here and then click here, I have to, okay. You have to create a node first to shift the origin of the grids. And instead, but this is the origin of the grids, not the origin, not the real origin of this global coordinate system. The real origin of this global coordinate system is to this point. So if I write, instead of clicking, for example, 0, 0, 0 here, the origin of the grid and the origin of the real global axis coordinate coincides. They overlap each other. Another thing is here, you understand, starting from 0 to 10, in 1 meter spacing, the grids are provided to the user to be able to draw its frame or other structure. And there is another option here, it's skew. So let's write something here in skew to understand its meaning. It's also, as far as I know, the angle. For example, in its direction, I write here 45. You see, this is in the first glance, it is not easy to understand what happened here. it's an angle. It's an angle 45. Scale is an angle. Okay. The x-axis is rotated 45 degree. 45 degree. Nothing happened to the vertical axis. Okay. And we are still in xy plane. The grid plane is still in the xy plane. We can, if I look from top, you can see that. Okay. So this this grid structure is in the xy plane. This is not an isometric view. Okay. If I write 45 here, the y-axis will be rotated in 45 degree. So I will obtain a new grid as you see here. So I want to write the default values here to get the default grid back. Okay. So I think it is enough. It is enough to learn about Snap Node Beam, easy to drawing tool. I think we have spoken enough about this tool, and by means of this tool we can easily draw our plates, our frame structures, especially our two-dimensional frame structures. We can easily draw by means of this. For our three-dimensional structures, we can also use this. We can sometimes shift the places. We can sometimes shift the place of our grids, or we can sometimes need to rotate our grid. And how those things are done, I told here by means of this edit menu, some things are done. But I think for the fresh starters, so much speaking was enough. Now let's continue. I think it is now important to understand what this tool is, and instead of speaking and telling very much about this thing, a bit, and the general understanding of this tool is enough now. Now let's continue creating a model, a simple model. Now I don't need this tool anymore, and I will stay in this XY, always in this XY plane. Now what we do to create a model, we draw it members, column, beam, column, floor, shear wall, and all load carrying members to sustain the structure. I built here a very easy two-dimensional frame. What we do is one, creating the model. The second thing is determining its boundary conditions. Determining its boundary conditions are supports. It is done from here, support page. Okay. From here, to create a support definition, I click on here. Here we have different support definitions ready for use. You can choose one of them. This is for fixed support. You know the definition of the fixed support. Click on add. So we added this support type to support page. And then to assign this fixed support property, this fixed support to a node, we use cursor to assign. Okay. In graphical interface, we generally use this. And then I click assign. Now assigning appears. And click on the points. which of them I want to assign the fixed support, and then I click on close. And what we do next to complete our structural model, we have to assign it some cross sections and materials. This is easily done from here. It's property page, it's called. Now here to define a section, I click on this. You know, here this section is circle, for example. You can rectangle T and some other things. Better not to speak about them. And our aim is just to learn how to build a model, the steps of building a model in Staad Pro. Actually, in many structural analysis programs, the steps are same, but the methods of applying steps may differ. For example, here I give some in meter. Remember, our length unit is meter. Let's say it's the depth of the beam is 0.35, 0.3, and 0.25 is the width of the beam. These are also the local axis of the frame members. Here in Staad Pro, it's called beam. Its material is assigned as concrete. I will not change it, and I don't speak about it now in this video, how it is done. Now you see, using the property page, we can quickly create a cross section, choose a cross section, and also its belonging material, and then click here, add, close here, and I have to assign this cross section and material, the two properties, to the beams. To use cursor to assign. Okay, I assigned my beam and my columns, all of them the same property, and I click here to finish the assigning, and then say close. The last thing is assigning loads. Load page. Now load page. In the load page, load case details, not that this one, load case details. We have to add first of all one load. This loading type shall be chosen. It can be also none, but I prefer writing here one dead load. Its user defined name is dead. I added it here. And one leave load, and let's write here leave. I added here, and then I say close. You see, I have two load cases, dead load and live load. But to dead load, I have to add the real load, the value of the dead load. And after I choose this, I click here add. Its self weight. What is its self weight? Its unit weight times its volume. Since it's a gravitational load and the vertical axis is y, in the global axis y direction, factor -1. These are always default, and you have to keep -1 here same. You have to keep this value to apply the structure's own weight to the structure. Click on add. And as that load, for example, there is some, because of some uniform things, maybe is distributed, put on those on that beam, and as a result, some member uniform force load maybe here on that beam. So that's right, minus 2 kilonewton per meter, and global y-axis is upwards. So I put here negative sign in front of 2. If we want to place this force not distributed completely on the beam, but limited to the some length of the beam, you have to write some values here, but I don't want it now. I click here add and then close. But now those loads have values, but they are not assigned to any member. Okay, so we have to assign them. So self-weight is classified as dead load, but this to be assigned to the load carrying members. So for example, now I want to assign self-weight to the all members, okay, the two columns and beam. So I select here, I can also use cursor to assign, but assign to view, I can see all the members in the view. Assign to view, I select, and then I click on assign. So this load is assigned to all members. And this load I want to assign. But I want to assign this dead load only to the beam. So instead of assign to beam, I can do this again and assigning. When I assign the load, finish. Okay. So I want to define a live load now. Under live load, I defined the live load. I have to define the value and type of the live load. Again, a member load. Or better, let's make a nodal load, live load, and in the x direction, let's say it's concentrated force, 20 kilonewton. Close. And I have to assign this. Use cursor to assigning. Okay, I assigned this. Assigning, close. Sorry, I closed it. It was load page. All of the loads are assigned now. So what we do next as a structural analyst is analyzing performing the structural analysis. For that reason, I click commands, analysis, perform analysis, print option, no print, okay. It's linear static analysis. Analysis, run analysis. Now we can stay in this window in the model mode, or go to post-processing mode, or view output file. Let's view the output file. Now this is the output file. Okay. Let's close the output file. Now let's go to the post processing. Or instead of going to post-processing, okay, let's go to post-processing. Selected load cases are those cases. Let's say, okay. Now you see deflection. Now deflections are shown here. Here on the table, under dead load or live load, the deflection or displacements and rotations or nodes are given here in this table. This is the important thing. Visually, we can see it by clicking this icon. Okay, under live load or under dead load. Now under dead load, but we have to we have to increase the deflected shape by means of a multiplication factor to easily understand the deflected shape of the frame. For that reason, the user shall press and hold to the control button in the keyboard, and then use the scroll of the mouse. Play with the scroll. Yeah. Play with the scroll, and then okay. Now you can by eye better understand the deflected shape by magnifying the deflected shape. Okay, that's okay, and let's finish the video and save the model. Its destination folder were predetermined by me in the beginning, or if you want to save the file as to another folder, you can, as we all know, use another option. Structure 6. Let's say, I started the project several times from the beginning to illustrate some things of Staad program. The last name is structure 6. I want to use the intro again. Let's write introduction and save it. Okay, its name is introduction, and then finish the program. Okay, thank you very much.